Welcome, everybody. I appreciate you showing up today. We're going to talk about migrating NFS workloads to Azure Blob Storage. My name is Klaus, and it's good to see you here. So the first question is, why do you even do this? So customers have been pretty clear that they're using NFS on-prem, and they want to lift and shift those workloads up to Azure. They've also been clear that by doing that, they don't want to have to rewrite the application, and they also want to make use of that application data up in Azure for Azure Search, ML, and other services that we have. Some existing solutions that do that today act as an API gateway. So they traverse the Blob REST API from the NFS API. And customers are pretty clear saying that sometimes that adds additional cost and complexity, and sometimes uses a proprietary format that disallows that data being used up in Azure. So that's not always a great idea. And also customers said they wanted to use the same throughput and capacity that we have in Blob Storage, which by default is 2 petabytes and 50 gigabits per second in and 50 gigabits per second out in EU and US and other regions. So with that, I also want to take a step back and talk about how this fits into the larger frame. I went a little fast. I was going to ask, how many people here know how many core Azure services we have? A little too late. We have 3. So we have disk storage for our compute workloads. We have object storage for blobs, which are basically binary large objects. And then we also have file storage, and we have 2 offers there. We have Azure Files, and we have Azure NetApp Files. And we typically also talk about data transport, how do you get data into Azure, as well as hybrid solutions. And I wanted to draw attention to one of them here, HPC Cache. How many people here feel like they have a pretty good understanding of HPC Cache? Oh, this is wonderful. And we have somebody here to keep me honest about HPC Cache as well, but I'll take a slight detour to talk a little bit more about that, because that is one way to add NFS up into Azure. So HPC Cache, at the end of the day, allows you to set up a high throughput NFS endpoint very close to your compute, which caches some remote storage. So the storage could be up in Azure, or it could be on-prem. So the 3 discrete values it provides is that high-speed throughput of NFS, and one workload that uses HPC Cache a lot is media rendering. Media rendering tends to use many, many, many compute VMs. It tends to work on very, very large files, and it's very, very read-heavy. When you think about rendering a cell of a movie and doing it again and again and again, that's what that workload looks like. Another value is the fact that they allow that storage to remain wherever it is. If the storage is on-prem, it stays on-prem, and only the cache sits up on the cloud next to the compute VMs. So it gives you that value as well. And third, it can aggregate multiple storage containers or on-prem locations into one single namespace. So if, for instance, you need to have a namespace that's larger than 100 tebibits, HPC Cache can do that for you. So for instance, if you're using NetApp files, you are constrained by that volume size. You can get beyond that with HPC Cache. And the reason that's important is because when I'm talking about NFS, I want to give the full picture. The first one is the NFS solution we're building on block blobs. It will be ideal for read-heavy workloads with larger files, where if it is an HPC workload, there are minimal updates happening to those files during runtime. It'll still work, but it's not really the best use case for it. And we think that the NFS v3 on top of block blobs will probably provide the lowest cost compared to the other offers. We are previewing this quarter, and at the end of this slide, I'll show the link where you can register for the preview. So I'll contrast that with, I'll give you a sneak peek. Azure Files is adding NFS 4.1. So they have a session on Friday. I'll give you the information for that as well. But that 4.1 solution will be based upon their premium files offer, so that's SSD based. And so that gives a reasonably decent throughput and IOPS, and transactions per second. The preview for this will come out next quarter, so not this year. So that's coming in a little bit later. So this is kind of a sneak preview, if you will. And it will provide, on NFS 4.1, full POSIX and locking support. And then the security initially will be VNet only. And then we have Azure NetApp Files. Azure NetApp Files is our fully managed, powered by ONTAP solution, which is actually NetApp hardware running in our data centers. So it has all the same functionality that you would expect to see on-prem, including NFS v3 and v4.1 support. So basically, if you're not sure or if you need both protocols against the same data, then ONTAP Azure NetApp Files is the way to go. I'll also add that the latency for Azure NetApp Files is quite low in our data centers. So we've done a lot of work to make sure that the latency is low from the compute resources that access it and is in the sub-millisecond range. And then lastly, the thing I just did a little detour for, HPC Cache, is basically the fourth offer that provides an NFS connectivity up in our cloud. That's going to work really well if you have a scale-out workload with hundreds, if not thousands, of VMs accessing the same data. And it works really, really well for larger files and that rendering sort of use case that I mentioned before. And lastly, again, it allows you to put that cache very close to the compute. So even if the NetApp, Azure NetApp Files, or the Blob Storage is in one region and your compute is another region, you can use HPC Cache to create that dynamic cache close to the compute instances. So looking at it all together, this is what it looks like. And one reason why I'm spending more time on this is because this can be a little confusing. We've already gotten customer feedback and some of the customers that we've exposed this to that you sure have a lot of NFS offerings all of a sudden from hardly none at all. And that's actually a true statement. And so the way to read this is if you need v3 and you think it's going to be a read-heavy workload and you're worried about the total cost, look at the Blob solution that we're previewing in the next month or two. If you do need NFS 4.1, full POSIX, hierarchy, as well as reasonable performance, Azure Files is probably a pretty good solution. If you're currently using NetApp or you want to use the data management that ONTAP provides, then Azure NetApp Files is a good solution. And they do actually have on the 3 tiers, on the highest tier, they have a very good IOPS rate. So that's NVRAM. And then fourth is HPC Cache to also look at, which provides different values and different functionality than the other 3. Any questions so far? Yeah. It's loud here.
For the Files offering, is it NFS or CIFS?
So the question was on the Azure Files NFS offering, is it going to be just NFS or NFS and SMB? The initial volley will be dedicated, but they're working on actually making the protocols concurrent. And across Azure, we really want that concurrent protocol story to sing because that's one of the differentiators that we have today. Any other questions? Cool. Duh.
Which ones support cross-regional rep?
Which one supports cross-regional rep? As in GRS? They should all, well, Azure Files and Block will both support cross-regional replication. HPC Cache is more of an ephemeral solution, so it doesn't, it's backed by GRS or LRS. Any other questions? I like the questions. It makes it much more dynamic. Okay. So talking about NFS, I want to take a detour and talk a little bit about ADLS Gen 2. And the reason is because we're building on top of the work we did for ADLS Gen 2. So when we started with that, we had this current architecture, which was our REST protocol based on a common framework to provide our object store, which we call blobs. And what we did is we added the ADLS API, which also has folder functionality. So rename folder, create folder, delete folder, move file, those sorts of file system semantics built into that API, which we don't have in the Blob REST API. And then we used HNS to provide a little bit more functionality for that stack. And my next question is, does anybody here know what HNS stands for? I see one hand. Oh, this is good information, new information. So HNS is hierarchical namespace. And the only reason I listed it as HNS is because I wanted to see how many people knew what it was. But it's hierarchical namespace, and that's what sits on top of that common storage foundation to provide a folder-level hierarchy and folder-level ACLs. Okay? And so now, once we built this, we basically said, now we have something we can use for multiple protocols, including protocols that require file system semantics or a hierarchical namespace, namely NFS. And so what this shows is that account across the type is one account that can now provide both ADLS Gen 2 API, Blob API, and NFS v3 functionality. Without having to move the data from one silo to another silo, it all stays in place, no copy required. The next tier is, on the ADLS side, is called a file system, because that's just what the language that Hadoop tends to call it. On the Blob side, we call it container, and then NFS v3 calls that an export that you actually mount. And then beneath that, you get the directory of the file that's what you'd expect. Now, in the first version of this solution, what we'll actually have is we want to match the perf and scale of the block blob container or storage account. So the same petabyte scale that we support today, the same gigabit per second that we support today, that's what we're aiming for our GA release of that product. And we also are going to support the same endpoint. And that's interesting for anybody that currently has a network topology that's locked down, and they're allowing specific access and disallowing other access. So the blob endpoint, which you use to get to the blob data, is the exact same endpoint that you'd use to get to the NFS data, which means the network configuration should be simpler and more consistent. The one thing I will mention is we won't support hard links, NLM locking, or AED integration in the first version, even though those are things that we're starting to work on as well. Any questions on this? Yeah.
Will it support any encryption in transit or Kerberos type functionality?
So the question is, what sort of encryption in transit will you support, or Kerberos authentication in the future? I do not know if NFS actually supports HTTPS. For our other protocols, we always have HTTPS for any endpoint communication. I'm going to hazard a guess that NFS could support it. There's some extensions, but I haven't heard that we are going to in the first release. The security that we're expecting to go out initially is with a private VNet, because there won't be an auth story to NFS v3 in the first version that we have. So you will have to set up a private VNet, and all access will be within that VNet. So really, to kind of sum up those features, we basically are going to have our first, or I should say our second multi-modal public cloud offer, because we're adding our third protocol on top of Blob Storage. It's really for lifting and shifting of NFS read-heavy workloads from on-prem into the cloud. It will make use of the hierarchical namespace that ADLS provides for us, as well as interop once we get to GA and beyond between the Blob API, the ADLS API, and the NFS API. And that's the list of the specific workloads it's really going to be targeted for. Now I have a short demo that I pre-recorded because I knew this was going to be a short session, and I didn't want to mistype my password 3 times in a row. But the client mount command that you'd use is exactly what you'd expect if you'd used Linux or Unix to access an NFS volume. This is exactly the same. The only difference is that we're using the account name, the fully qualified path, or the IP address, as well as the storage account name as part of the path name. And so here's a short demo that we put together before Ignite. So this shows Azure Storage Explorer, and what we're doing is going through a set of storage accounts. In this case, there's one called NFS, so that's the name of a storage account, which has a container, and within that container is the fact that it's HNS enabled. So we're showing that this is a normal storage account with HNS enabled, which is for ADLS Gen 2. The next thing we're doing is we're remoting into a Linux box. It happens to be a Ubuntu 1804. And then we're running that mount command I showed previously. In this case, we're using the IP address of the storage account, and then we're using the FS test base container name, or storage account name, sorry. And then we're going into there, and we're seeing that we do have a directory that we already made called vol.re. The second thing we did is we downloaded a test app called FIO for File Input Output, and we're running it against that same mount point. And then if we go back to Storage Explorer and look at what's going on there, we can see that that NFS test app is actually creating a file and operating on a file that's in that storage account. that we're now accessing through Storage Explorer over the Blob REST API. So we're showing the fact that we are concurrently accessing that same volume through those two different APIs. Now I'm going to get into pricing, and the first thing I wanted to do is just touch on the 4 different tiers that we have in Blob Storage today. So these are the prices. This is retail price that we have today. I think it's West US 2, and this is from our webpage. Initially, we're focusing on the hot and the cool tier for NFS. Primarily the hot tier, but the cool tier should be doable as well. And that's just for the initial release that we're going to put out. Once we do that, then we can actually work on extending it to our premium tier, which gives us the SSD-based performance as far as higher IOPS and lower latency. And also better for smaller object size. Now, the pricing for ADLS Gen 2, when you enable HNS, is approximately a 30% uplift on gigabytes as well as transactions. The the NFS v3 pricing is not set yet. We have not formally set it. But we are leaning, and I'm leaning a little bit to just pricing it exactly the same as ADLS Gen 2. So if you have any feedback on pricing, I'd love to hear from you after this talk as well. So our overall storage roadmap, in the last 9 months, we've released everything on the left-hand column. So Data Lake Storage Gen 2 back in February, the premium blob, which is SSD-based, data lifecycle management, which moves blobs between tiers, and all of these features will work with NFS, which is why I'm showing these. So it's not as if we're just standing up NFS as a standalone service. We're adding NFS to an existing service that includes all this functionality. The Azure AD integration, which we will not have initially for NFS, is the AD auth to get to your blob store. And the high throughput block blobs just means that we have faster ingest and egress for our blob storage accounts. On the right-hand side, we have the multi-protocol access, so we are GAing some additional functionality where you can currently use the ADLS Gen 2 API and the Blob API on the same data set at the same time. So that's not something that we had before, and that's part of that whole multi-protocol promise. Customer-controlled failover by the end of this quarter, which will allow you to fail over a GRS account from a primary to a secondary. Reserve capacity, so we announced the ability to pre-purchase storage at 1 to 3 year increments at specific block sizes at a 30% discount. And then last, object replication, which will allow you to specify a source and destination storage account and replicate your blob storage between those. So at the booth, which is right underneath that infrastructure banner a little bit to the left, you can find any one of us to talk more about this if you want to. We also have a preview at aka.ms, Azure NFS Preview, Azure NFS Preview. So you can just sign up there, and then we'll get in touch with you for the preview. And last but not least, so here are the other storage-specific sessions, and the one I wanted to bold out is this one on Friday, which is specific for Azure Files and Sync, and they will also touch upon the NFS 4.1 offer that's coming out in the future. Any last questions? Yeah.
Are there plans for a Kubernetes CSI driver for either of these?
The question was, are there plans for a Kubernetes CIS driver? Not that I've heard of. Not that I've heard of. Any other questions? Yeah.
Right now you do SMB and NFS on the same multi-protocol, on the same storage account?
The question is, when we support NFS 4.1 on Azure Files, will we support concurrent access? When we first bring it out, I believe the answer is no, but that will follow, that will do concurrent access, similar to what we did with ADLS Gen 2. With ADLS Gen 2, we shipped ADLS Gen 2 where you could designate it's an HNS-enabled account, and you could use Hadoop or Databricks or another sort of data lake analytical package against it, but you could not use the Blob APIs. But we just GA'd that functionality as well, so it'll actually follow in the same pattern. Yeah.
So adding the high-performance cache in front of the NFS would also give multiple access, I assume?
We'll provide what?
Multiple access, because if you have 1,000 VMs accessing the same set of files, you had to have provided multiple access on top of your system.
Got it. So the question is, if you want to scale out to thousands of discrete VMs or containers that want to access the storage, would HPC Cache provide value? And the answer is definitely. Accessing the same file? Yes. Up to the locking constraints. And if we want to, you can talk to him, this fine gentleman here, Scott, about how HPC Cache can be tuned as far as what the behavior is for concurrent access. Yeah. Yeah.
In the demo, you showed that the machines is accessible through the VNet, inside the VNet. Is it possible to access the NFS from outside of Azure, from, let's say, over Direct Connect or something like that?
The question is, will we provide access to the, I'll say, the NFS v3 offer across the internet or from a private VNet? And in the initial solution, it'll be on a private VNet, and we just did preview private links, which will allow you to actually have a private VNet from on-prem tunnel through to a storage account, which means that that would be allowed. Yeah. Yeah.
Support the Mac clients with NFS?
The which?
Mac.
Like Mac OS? Ah. So the question was, would we support the Mac OS client running NFS against these? This is going to be industry standard. So I can't say we've tested it, but I can say as long as it's talking NFS v3 or NFS 4.1, it should work. But wait, I haven't tested it. The devil's in the details. Any last questions? Yeah.
Are there any HPC Cache sessions at 1 p.m. on Friday as well, in case anybody wants to hear them?
I don't know. Is there?
Well, yes, there is.
So if you missed that shameless plug, there is also an HPC Cache session on this Friday, and I'm sure Scott would tell you exactly where it is, and maybe even give you a preview if necessary. And if you have any other questions, feel free to hang out afterwards, and we'll make some space for the next talk speaker. Thank you so much.